All right, we're at 3:45 Alaska time, so I'll go ahead and get started. Thanks everyone for joining the call. I just wanted to take a quick moment to introduce myself. I'm Lalani Dunn, the Executive Director of the BBRSDA as of last month, actually to date. Um, on the call, we have our entire staff, Becky Machine, our financial administrator, Francis Birch, our program manager who leads quality, sustainability, and member outreach, and Aubrey McNeil, our marketing and creative manager that works predominantly with the marketing program. I know we have a handful of our current board of directors on the line as well. There are a few important dates that I just wanted to note before I introduce our presenters today. The last day to vote for our board of directors election is on April 9th. Paper ballots have been mailed and electronic ballots will be going out this upcoming Monday. And for further details, you can visit our website election page that Aubrey will be plopping into the chat. Thank you, Aubrey. Our next board of directors meeting will be on April 16th, and details are posted on our website, and a meeting notification will go out within 1 week. Francis, can you go over some quick Zoom webinar instructions for everyone?
Yep, absolutely. So we'll take questions kind of at the end of each of our four presenters' presentations. And so if you'd like to ask a question or comment, you can enter it into the Q&A, which is an icon at the bottom of your screen, or you can raise your hand, which is an icon at the bottom of your screen if you're on the computer. And then as host, we can unmute you when it comes to your turn. If you are on the phone, you can press *9 to raise your hand, and you'll be unmuted when we call on you. And then I have gotten a lot of questions. This meeting will be recorded and we'll get that up on our website Monday, if not sooner. Thank you.
Thanks, Francis. All right, I'd like to introduce first is Chris Boatright, the General Manager and Research Scientist with the University of Washington, Alaska Salmon Program. You'll be able to ask questions after each of our speakers today, and you could always utilize the chat function as well, as Francis mentioned.
All right. I guess I'll get us started. I'm Chris Boatright. Thank you for the introduction, Lalani. And thanks to everyone who's joined us out there online. I'm going to start today with a review of the 2024 Bristol Bay sockeye salmon preseason forecast. And so when I do these reviews, I always like to start off the review of the preseason forecast with what I think is the most basic forecast table we generate. And so what we're looking at here on screen is in the body of the table are 36 individual predictions that sum to give us a total return forecast for Bristol Bay or fish sockeye expected back in 2024. The total number there is actually 38 individual predictions, but 2 of those predictions aren't shown on this table. So 36 individual predictions. That's a prediction for each of the 4 dominant age classes of sockeye that return to Bristol Bay each summer. That's 1-2s and 1-3s and 2-2s and 2-3s. So the number to the left of the decimal is freshwater age, and the number to the right is ocean age. So a prediction for each of the 4 dominant age classes for each of the 9 major river systems in Bristol Bay. So for 2024, we would expect 44.85 million sockeye back to Bristol Bay. So from here, I kind of like to take a step back and look at the primary data set that these forecasts or predictions are built on. So what we're looking at here on screen is Bristol Bay sockeye salmon returns 1963 to 2023. So it's really a history of Bristol Bay in terms of sockeye salmon. So the first thing that always jumps out at me from this graph is, so each of the 9 major river systems is represented by a different color band. And so the first thing that jumps out at me is the Kvichak River system in yellow. And so what I see is just how dominant the Kvichak River system was in terms of overall sockeye production for Bristol Bay for much of the 20th century. And then as we headed into the late 80s and into the 90s, we began to see Bristol Bay sockeye production really diversify among river systems. And then as we keep moving right, the last decade, where we have seen record-setting returns, certainly characterized by relatively strong production across all the river systems. So it is this historical return data coupled with explicit age data for sockeye collected by the Alaska Department of Fish and Game each summer that is the primary data set that goes into these forecasts. So some of the predictions we in that body of table, we use machine learning methodology. And when we do that, machine learning methodology allows us to incorporate data sets such as sea surface temperatures or abundance of other salmon species during Bristol Bay sockeye's ocean phase. So specifically today, we're interested in the next chapter, so to speak. The 2024, what we forecasted for 2024 has now popped up on the right-hand side of the graph, just to give a quick look at how 2024's total number compares to what we've seen historically across this time series, 1963 to last summer. So from there, this is the forecast table as we release it in the first week of November each year. This is the 2020. So what we're looking at here is the 2024 Bristol Bay sockeye preseason forecast. On the left-hand side, we're looking at the same set of numbers that we started with, those 36 individual predictions that we sum both totals for the river, for each of the rivers, and then of course for Bristol Bay. Again, our 2024 expectations for Bristol Bay sockeye are right at 45 million sockeye. To the right of the river totals, we give an estimate of escapement. We get to those estimates for escapement by river system really by considering run sizes of the magnitude that we have forecasted for each of these river systems, and then the historical escapement numbers for each of these river systems given run sizes of certain magnitude. So we would predict an escapement of 12.91 million sockeye off a total Bristol Bay return of 44.85 million sockeye. We also provide in this table an estimate of fish expected to be taken offshore, or rather in this instance, the South Peninsula take of Bristol Bay sockeye. We set that at 1 million for expectations for 2024. We take both of those and we remove them from those river totals and from the total return number to come up with an estimate or a prediction for inshore harvest. So sockeye taken in the commercial harvest in the districts. So for a total Bristol Bay return of 44.85 million sockeye, we would expect an inshore harvest of right at 31 million sockeye. So anytime you're doing any type of forecasting, and certainly this is true here with this forecast, to get the most information out of the forecast, you really have to consider forecast accuracy over some time period. And so that is why we generate this plot each year. So this plot deals with that directly. It's a two-panel plot. The top panel there is percent deviation in the forecast from the observed or actual returns across this time series. In this instance, that's 2000 to 2023. So from 2000 to 2023, the observed returns or the actual returns for Bristol Bay are set to the 0 line. So red columns that fall above that 0 line are over forecast in those years. And the blue columns that fall below that 0 line were under forecast in those years. And across this time series, the percent error for the forecast is 15, or specifically mean absolute percent error is 15.3%. So the bottom panel is even simpler than that. The actual or observed Bristol Bay returns are the blue data points connected by a dotted blue line. And then, of course, we overlay with that in the red line our forecast in all those years. And really, this just gives you an idea of how our preseason forecasts have actually tracked with the actual returns that we saw in Bristol Bay. Okay, so the next thing for anybody, any of you out there that have taken a look at the forecast over the last 12 to 15 years, one thing you'll know that we do is we take our preseason forecast and we translate it into a Bristol Bay sockeye forecast in pounds. So in this instance, we organize our forecast in pounds, or organize this forecast table again by the 4 dominant age classes of sockeye that return to Bristol Bay each year, and by the 5 commercial fishing districts. So for a harvest of 31 million sockeye in Bristol Bay, we would expect that to translate into pounds taken in the commercial fishing districts at 166.52 million pounds. Also, we can see that there's relatively good distribution across the expectations across the districts, with Naknek, Kwijak, and Nushagak being very similar, and the largest expectations for fish and pounds taken, and then a strong expectations for U.Washington as well. So to translate the preseason forecast into a forecast in pounds, we have to estimate or make predictions for the expectations of fish size or sockeye size in pounds for 2024. So in order to do that, we used for 2 ocean sockeye, the average weight for 2 ocean sockeye expected back in 2024 is at 4.8 pounds, and the expectations for the average size of 3 ocean sockeye in 2024 at 6.5 pounds. So on the screen there, the plot that popped up in the middle of the screen, if you see the blue data points connected by a blue line, that is the actual annual average size of Bristol Bay 2 ocean sockeye. And then the red data points above that are the average annual size in pounds for Bristol Bay 3 ocean sockeye. And then, of course, over there on the right-hand side, you'll see a blue and a red data point with a white center. And those are our predictions for sockeye size in 2024. And what you'll notice probably is for size at age of sockeye, we expect that to come up in 2024. And certainly if the forecast holds up and our forecast comes in the mid 40s, we do expect that size at age to take a tick up in 2024 to average 4.8 for 2 oceans and 6.5 for 3 oceans. So I thought I would take a little bit more detailed look at exactly these estimates we use in our forecast in pounds for 2 ocean and 3 ocean sockeye. So what I did is I took really that kind of same data set we just saw in that last graph, shortened it to a decade. So we're looking at 10 years of data here. Again, blue data points connected by a solid blue line were the average annual size of Bristol Bay 2 ocean sockeye across this time series, so 2014 to 2023. And the red data points connected by a solid red line were the average annual weights of Bristol Bay 3 ocean sockeye across 2014 to 2023. And then the blue data points and the red data points connected by a dotted gray line were our estimates or predictions for sockeye size in those corresponding years. So really, what we see is that these predictions have been fairly good. For two ocean across this time series, the percent error has been 6.4%. And then for a little bit more variability in three ocean with a percent error at 7.5%. And so really for a number of years, what we were doing is taking the most recent 20-year, so the most recent 20-year average, and in some cases, the most recent 10-year average for Bristol Bay sockeye, and using that to estimate sockeye size for the coming year. It worked really well for a number of years. Certainly for all those years where total Bristol Bay run size was bouncing around between 25 million and 40 million sockeye, it did pretty well. But then after 2015, the runs got really big and the sockeye started getting really small, and we can see a little bit more variability between our sockeye size predictions and the observed sockeye size. So it took us a couple years to react, but we changed how we were doing this a little bit. And basically what we started doing is considering all the years across the entire data set, taking the average annual weights of sockeye from the 10 returns that were closest to the returns we had forecasted, to the run size we had forecasted for the coming year. And we used that average to come up with a prediction for size of Bristol Bay sockeye in the coming year. We can see that certainly over the last 3 years, it's worked pretty well. And again, we would expect that if the forecast holds and total return for Bristol Bay is right in the mid 40s, that those predictions for Bristol Bay sockeye size are likely to be pretty good. So with that, I'll stop and we will try to field any questions.
Thanks, Chris.
Yeah, are folks able to raise their hand? Maybe, I hope so, but please let us know.
I guess I'll turn off my screen share.
Okay, I'm not sure if there's not questions or perhaps if it's an issue on our end, we will work on sorting that out.
Oh,
But
I
we've
see
got
a
a
hand up, actually. Eric Anderson. Let's see. Eric, you should be able to talk.
Awesome, thank you. I figured I'd give
Yeah.
you a test to just see if the system was working. It is also working, but I also had a question. So first off, really great analysis, and I understand how the trends have been, the model's been adjusted over time and you've been reacting to the data. Two questions. First question is it seems like the larger runs have been correlating with smaller fish. Have we seen any exceptions to that?
No, that relationship's pretty consistent over the long term. So the bigger the run, generally the smaller Bristol Bay sockeye size we see. There's some other variables. Actually, Daniel Schindler's done quite a bit of work with Bristol Bay fish size and all the different things that affect it. But no, generally that relationship holds up reasonably well.
Awesome, thank you. And then part two on the question would be, so obviously we've had some really incredible record years over the last couple of years, and it's slowed down a little bit. Causation is obviously the wild card there. Do you have any thoughts on, are we returning to a cycle, or is there a new normal, or what do you think's going on there with the trends? And that's my last question. Thanks.
I don't see any evidence that we're returning to a cycle. we'll just have to see where we head, whether these are a couple of down years relative to a decade long where we were averaging almost 65 million sockeye a year. One of the talk that follows mine here will look at specifically look at data that gives a little bit longer than a 1 year forecast on how that looks.
Thanks.
There's a question in the chat. Jamie asks, why is the Igigik return significantly smaller than the past few seasons? Escapement has been good and on pace for what ADF and G want.
Ooh, let's see. Curry, you got any thoughts on this? You know, it's for the Igigik returns, that is just how it stacked up once the models were run. Not sure why I think if I look back at Igigik, there a lot of Igigik's return last year was 3 Ocean, which is really kind of the end of the line for that year class of fish. So we had to move back to looking at 1 year or jack returns that a lot of the Igigik forecast was built on. So small 2 Ocean production there last year, very moderate jack production leads to a smaller Igigik forecast for 2024.
Yeah, the only thing I'd add to that is, in addition to sort of slightly lower 1-1 production, those jacks, those 1-2s, those fish that spent 1 year in fresh water and 2 years out in the ocean that returned in 2023 weren't in incredibly high abundance. So we wouldn't expect a lot of 1-3s this year that went to sea in the same year as those 2 Ocean fish that returned last year.
Thank you. I don't see any questions at this time. Go ahead.
All right. So our next presenter is Dr. Curry Cunningham, also with the UW Alaska Salmon Program. He's a quantitative ecologist, a former Bristol Bay commercial fisherman, and an assistant professor at the College of Fisheries and Ocean Sciences, University of Alaska Fairbanks. His research focuses on population dynamics and fisheries management.
Excellent. Thank you. I'm hoping you can see my screen here.
Yep.
Perfect. Well, yeah, thanks for the opportunity. I'm always excited to come chat with folks from the public and members of the fleet. And in addition to what Chris talked about in terms of preseason forecast methods, I'm going to be talking about leveraging some high seas salmon survey data that's collected by the NOAA National Marine Fisheries Service in collaboration with the Alaska Department of Fish and Game, and what that tells us about potential returns of sockeye to Bristol Bay in the next few years. And I'm coming to you from very sunny Juneau. Okay, just in terms of background, as Chris did a great job of highlighting, our current preseason forecast methods primarily rely on these, what I'm calling sibling relationships, these relationships between river system specific abundances of salmon returning in prior years, predicting the abundance of their older siblings the next year. So those 1-1 jacks in the Wood River that returned in 2023, predicting the 1-2s, those fish that went to sea in the same year and spent an extra year at sea, returning the next year in 2024. As Chris pointed out, we use a range of methods, dynamic, sort of linear sibling models, as well as machine learning methods. But I was really interested in exploring the potential utility of using some of these high seas survey data to see if we could get an additional perspective on the abundance of juvenile sockeye out in the marine environment in the year of ocean entry, and use that to inform our preseason forecast for how many adults are going to be returning down the line. And so, you know, these are already being used. So this is a figure from a paper of Jim Murphy's from 2016. So these, at least in the northern Bering Sea, these high sea survey data that are capturing, in this case, juvenile Chinook salmon or king salmon, are used to predict the return abundance of Canadian origin king salmon to the Yukon River in subsequent years, and there's a decent relationship there. And so I was really interested, can we leverage these same data and look at catches of juvenile sockeye in these marine surveys and use that as an additional piece of information to inform our preseason forecast for Bristol Bay. So just to orient you, what I have here, each panel is an individual year from 2002 up to 2023. Each of these points is an individual survey location. So up here in the north, we'll see in the northern Bering Sea, there's a survey that's conducted every year, more or less, collaboration between NOAA and the Alaska Department of Fish and Game. Further south, there's the southeastern Bering Sea survey that occurs every other year. The colors of these points are colored by basically the catch rate. So more yellow colors, higher catch rate of juvenile sockeye, more blue colors, lower catch rate of juvenile sockeye, and the gray points are basically places that they got water hauls with respect to juvenile sockeye. And so the cool thing here is that there's an index of these fish after they've left freshwater. So fish are out migrating from the lakes and river systems around Bristol Bay starting in April or May, places like the Wood River continuing on out through July, entering the marine environment. These surveys take place primarily, you can think about September, usually in and around September. The challenge with these data is that there is this imbalance across space. So as I said before, that northern Bering Sea survey occurs every year. Sampling in the southeastern Bering Sea here up into Bristol Bay primarily occurs every other year during the even years, and there's also a few gaps in the time series in 2020. There were no surveys due to COVID-19. So one of the key challenges is how do we fill in these gaps in space and time so we can come up with a representative index of juvenile sockeye abundance out in the marine environment. So that's the challenge. One of the benefits is that the vast majority of juvenile sockeye that you catch out there are Bristol Bay origin fish. And this isn't the same when we think about chum salmon captured in this survey, right? You have Asian chum, you have Western Alaska chum. Sockeye, they're all primarily Bristol Bay origin fish. So that simplifies things a little bit. So in order to make this work, we have to figure out some way to leverage basically the correlation across space in these observations to fill in some of these gaps in space and time and come up with a representative index of juvenile abundance, juvenile sockeye abundance that we can then relate to adults returning in subsequent years. And so there's a range of methods that are applicable for doing this. One is what are called vast models, and then we'll go into the details, but basically they're spatiotemporal models that leverage the correlation amongst these catches in these different survey locations across space and across time and use them to fill in these gaps. They've been used pretty extensively in the groundfish world. So what I have plotted here, this is the Eastern Bering Sea Shelf Survey. So the bottom trawl survey captures things like pollock and Pacific cod and crabs out there. Historically, this was the spatial extent. In about 2010, this survey started extending further north after it was pretty well noted that some of these major species like pollock and cod were going pretty far north in these warm years. So these spatiotemporal models have been used to basically extrapolate what abundance would have been in the northern Bering Sea in these years where we don't have any survey observations based on what the catch rates were at this southern boundary as far north as they did survey. If you know from the years where there was sampling in both places what that correlation is, you can generate an expectation for how many fish might have been up there. So this is already being used for species like pollock. And so I wanted to apply that to these juvenile sockeye data and see if we could infer something about abundance across space and abundance across time. So what I have plotted here is basically these predictions here for basically what we can think of as abundance density relative number of juvenile sockeye per kilometer squared. The more yellow colors are kind of higher abundance, the more blue colors lower predicted abundance. And so this is the year of the survey or the year of outmigration 2002. What I have down here is the year that fish caught in the survey in 2002 would return as 2 ocean fish in 2004 or 3 ocean fish in 2005. So you can kind of magic eye poster this thing, and hopefully what you see is that we've got this period of more yellow than blue. About 2006, we enter this period of a little more blue. And then down here, starting in 2014, we generally have more yellow in and around Bristol Bay here, right? So our prediction for the abundance of juvenile sockeye starts to increase in survey catches, or based on survey catches starting about 2014. And so that increase in survey catch rate for juvenile sockeye in 2014 corresponds to individuals that would have returned as 2 ocean fish in 2016 and 3 ocean fish in 2017. Now that aligns with what we've seen obviously in Bristol Bay, right? This increasing pattern of production starting after about 2015, when Bristol Bay run size, or at least return size, started to bounce upward. So bringing this together, what we have is this index across time. So it's the point in the uncertainty across time. This is the index of juvenile sockeye abundance in the year of ocean entry in there in the eastern Bering Sea all the way up into the northern Bering Sea. And so we see this period, this low period here between about 2007 up through about 2014. It starts to bounce up, increases up through 2019. This is 2019, the largest index for outmigrating juvenile sockeye. This is the gap year, 2020, when there was no survey, and then it dropped after that, bounced back up. So this is 2021, 2022, and 2023. And so these 2023 fish will be returning as 2 ocean fish in 2025 and 3 ocean fish in 2026. So with that in hand, we have this sort of index of juvenile sockeye salmon in the eastern Bering Sea in the year of ocean entry. In order to translate that into return abundance, we basically just need to align these outmigration indices with the year that they're actually going to return. So we can take this juvenile index that represents year-to-year variation of juvenile sockeye in the year of ocean entry, and we can use that to forecast returns by calendar year, basically by lining it up. So we're trying to generate a prediction for 2024. Those will be the 3 ocean fish that basically went to sea and were captured in the survey in 2021, and the 2 ocean fish will be returning this summer that went to sea in 2022 and would have been captured as part of that 2022 juvenile index. And by adding those together, we can come up with an index by return year for juvenile sockeye. So next step is to relate that to what we actually saw in terms of adult returns. So on the x-axis, I have the sort of high seas juvenile salmon index, basically aligned with the year of return. Each of these points is the relationship between that. So these are for years 2005 through 2023, and the observed run size in millions of sockeye. And so if we look at that, basically the prediction from this juvenile high seas index and the relationship between that and observed run size inshore, there's a pretty good relationship. We can also do the same thing. We take the natural log of that juvenile abundance index and regress that against run size, and we end up with a pretty good relationship. So at the end of the day, these bars are the observed run size for Bristol Bay year over year, right, up through 2023. These green and red lines are the predictions based on those high seas salmon data for the return abundance by calendar year. What we see is that in 2023, right, the prediction was a little bit higher than what we observed. 2024, it's predicting something in the neighborhood of about 50 to 55 million fish, depending on which of these models you use for 2024 and out to 2025. So to summarize kind of the key points here, these juvenile survey data seem to provide information on the abundance and of course the condition of juvenile salmon in the eastern and northern Bering Sea in this year of ocean entry. And one of the benefits of using this for predicting the return abundance of adults down the line is that this sampling, this fall sampling that occurs in September, happens after at least part of the major freshwater, after the major freshwater mortality and early marine mortality events. We can use these sort of space-time models to fill in some of these gaps from the patchiness in these survey data, which is necessary. When we do that, we get, I would say, a reasonable prediction for at least Bristol Bay-wide return abundance, R squared of about 0.78 to 0.82. So the nice thing is that relative to the kind of sibling-based preseason forecast methods that Chris was talking about, this is somewhat of an independent look at what's coming in terms of returns to Bristol Bay sort of 2 years in advance. And I say independent because it's not based on the number of adults that returned in previous years. It's based on the number of juveniles that were seen, or at least smolt seen out in the marine environment, and projecting those forward in time. So as I said before, survey data up through 2023 generates a prediction for Bristol Bay run size in 2024 and 2025, somewhere between 50 and 55 million. So a little above our current preseason forecast, but again, you know, it's sort of all pointing to the same idea that relative to the production we saw in 2021 and 2022, we're looking at something slightly lower for 2024 and certainly into 2025. Yeah, I think I'll stop there. Oh, one final point. So I was just at a meeting this week, and the Alaska Department of Fish and Game is going to be kicking up some additional sampling as part of the Salmon Ocean Ecology Program. So Katie Howard and Sabrina Garcia and Ben Gray are putting in an effort to do some additional sampling in the southeastern Bering Sea. And as those data become available in the coming years, the hope is that we can bring this in and even provide hopefully even better estimates of juvenile abundance out there that can inform our expectations for adults returning in future years, among other objectives for that survey. Thank you.
Thank you. We've got one question. Stosh Anderson, you've had your hand up. You should be able to speak now for your question. Stosh, if you're there, if you unmute, you should be able to talk. Okay, I'll read one from the chat while he's sorting that out. I have a question from Ivan Sargent. Any info on king bycatch or why we are seeing less king escapement, especially in the Nushagak River?
Yeah, so you know, in addition to obviously catching juvenile sockeye out there, they catch juvenile king salmon and chum salmon, and so we have some work ongoing to try to leverage these data in the same way. As I said before, you know, the juvenile abundance index and at least the northern Bering Sea has been used to try to predict returns for king salmon on the Yukon River. Less has been done with the southeastern Bering Sea survey data and relating that to the Nushagak district, but hoping to move in that direction. And in addition, we have some work ongoing looking at chum salmon, obviously as a species in the spotlight right now, given low returns. Same kind of methodology, thinking about, okay, can we fill in these gaps in space and time to sort of give some idea of how many juveniles are out there in total and what that means for fish coming back in future years. But nothing specific to the Nushagak.
Okay. And then I've got one more in the chat. And Stosh, if you can hear us, I think you should be able to unmute. You've got talking permitted. So I'll read this one in the meantime and see if you're there. Another question, do we have any idea or theory as to why the number of fish going to the ocean is in decline?
Let's see. So the number of fish going to the ocean, like the number of outmigrating smolts? Yes.
I'm guessing so. It's in the chat here.
Look back at the smolt data to see to what extent we're actually seeing reduced numbers actually entering the ocean. We're certainly seeing some, and this is over the long term, changes in at least in some river systems, the amount of time during these warm years that sockeye are spending in fresh water, whether it's in places like the Kwijak system, where I spend a lot of time, right? In the real warm years, we've seen more of those fish go out after 1 year in the lake rather than 2 years in the lake. And this is a broader phenomenon across Bristol Bay when you look at across a longer time period. But in terms of juvenile outmigration numbers, I'd have to look and see to what extent we've seen declines.
I don't think there's any evidence for declines of smolts. For sockeye, there is probably for Chinook, but not for sockeye.
Yeah.
Thank you. Oh, I see another question for Eric Anderson. Here you go.
All right, thank you. Dr. Curry, great presentation. I had a question on the predictive model itself. So I remember some really old classes a long time ago. That seems like the R value is really good. But do we have any other predictive model that's better, or would you say this is our best model to date? Thanks.
Well, so there's the challenge, right? Is I'll go back a slide, right? So just based on when these surveys started in the early 2000s, to some extent, basically the early 2000s, this is only over 2005 through 2023. You know, if I could go back in a time machine and encourage people to start doing some of these surveys earlier on, we'd have a larger frame of reference. So it all should be caveated that, you know, predictive performance is only within this 2005 to 2023 time period. There's always potential for these relationships to fall apart, of course. But you know, from where we were at right now, it seems like it's performing reasonably well, at least over this time period. You know, if we see, you know, further reductions in high sea sampling, the uncertainty in those estimates is certainly going to go up, particularly if we see less sampling in the southeastern Bering Sea. But that's why I'm so excited that ADF and G will have this additional surface trawl survey effort, sort of targeted in the Kuskokwim Bay region, but also extending into Bristol Bay. There's some additional challenges with that, sort of different trawl gear being used, and there's a few things to work out. But you know, the more information we have on the juvenile portion of life history just adds to, I think, our overall understanding of kind of the ups and downs.
Got it. Thanks.
Mhm.
You. Stash, are you able to unmute? I'll give you one more here.
I can put my email in the chat if people are interested. You're welcome to follow up.
That would be great. All right, I see a question from MJ. Go ahead. MJ, if you unmute, we should be able to hear you.
How about now?
Yep, we
Gotcha.
can hear you.
Yeah, thank you all for being here. My question is for you, Curry, specifically, but it involves the other panelists. I know that there's increased spawning habitat because of the ocean warming in the Nushagak district. I'm wondering if you're seeing that in the Kwijak district as well.
In terms of habitat, you know, one of the things that we're seeing that's really interesting. So in addition to this temperature relationship in the Kwijak between freshwater life history and some of this work goes way back before my time, you know, when you have warm conditions, fast growth, those fish tend to not spend that extra year in the lake before going out to the ocean. We've certainly seen that. We also see kind of some interesting relationships between sockeye and stickleback, another major consumer of plankton in the lake, where the stickleback seem to do quite well and in some cases produce a second brood in these really warm years. And so one of the things we've noticed in, you know, 2019, extremely warm years, everybody knows, are the sort of the ratio of sockeye to stickleback in our surface trawl surveys in the lake was quite a bit lower. I mean, we're just getting tons of stickleback and fewer sockeye. Since we've seen cooler conditions in 2022 and 2023, more closer to what we've seen in the past, that ratio has shifted back to being dominated by sockeye, which seems like a good thing from my perspective. I know that doesn't address your question about habitat.
Yeah, I was just going to bring that up, but thank you.
Yeah, maybe just to clarify, MJ, I think the proposed hypothesis is that it's not that more spawning habitat's available, it's better rearing conditions. So as the lakes are warming up, they're becoming more productive, and maybe that's what you're thinking of.
Actually, if you remember, you took me to one creek that was very productive, and then we hopped in the skiff, went about a half mile down the beach, and you said in a few years this is going to be warm enough to become productive. So that's what I'm speaking to, is actually more habitat coming online in the Kwijak area with the warming.
Yeah. I don't remember the streams we were looking at.
Yeah, I would have to think we don't, I mean, there are some cooler, higher gradient streams, but I mean, there's pretty good utilization of the habitat that's available in at least most of the streams at the northeast end of Iliamna um, over time.
All right. Thank you, Curry. We're going to move on to our third presenter, Dr. Daniel Schindler, who is also with the UW Alaska Salmon Program. He is both a professor and principal investigator with a special focus on how aquatic ecosystems respond to changing climate and land use and interact with fisheries. He has a long history with the Alaska Salmon Program, which has studied salmon in Southwest Alaska since the 1940s.
All right, thanks, Lilani. Can you confirm that you can see my screen?
I can, yes.
Okay, great, thanks. Yeah, good afternoon, everyone. Just a quick update here on a couple things. One is a new forecasting product that we started producing last year after working on it for a couple of years. And then the second is an update on the state of the ocean from a temperature and climate perspective. Okay, so to talk about the forecasting, the new forecasting product, just want to talk through sort of the timeline of activities, both from the perspective of the fish coming back to watersheds, and then work by the Alaska Department of Fish and Game to enumerate those fish and age them, and then how our forecasting activities mesh with all that. So if we start in the fall of every year, a run reconstruction is done where Fish and Game takes all the fish that were enumerated in counting towers, fish that were caught in the fishing districts, and puts those fish in brood tables. So it's basically taking fish that were caught and allocating them to each of the major rivers. And historically, we waited for those data, which became available in, I think, the end of October typically. And by about Thanksgiving, we produced this preseason forecast that Chris Boatright just talked through. And then by winter to spring, we met with the processors and with the fleet and basically communicated these results out. Then, of course, summer arrives, people head north, and the season kicks in. Curry and Chris do a bunch of in-season analyses to interpret how the run is developing in June and July. August, people pack up and head south. And then again, we wait around for the data to be compiled appropriately until October, and then come up with the preseason forecast in November. What we realized a couple of years ago is by August of every year, we were always talking about guessing how many fish were going to come back the following year. And we decided that we could actually look into making a forecast in August based on the data that were available in August. So for instance, this is the last daily of July that is sent out. So probably Tim Sands from Fish and Game sends this out at the end of the July. And basically at this point, most of the fish have made it back into Bristol Bay and were either caught or counted in the counting towers. So in 2022, for instance, over 78 million fish were caught, which was, the bulk of the run in that year. On top of that, Stacy Vega and her crew from Fish and Game has at this point aged a lot of fish over the course of the season, both fish caught in the fisheries and also in the escapement projects. And basically by August 1st, sorry, I'm trying to get a highlighter going here. By August 1st, we have a really good idea what the age composition of all the fish that are returning to Bristol Bay is. So at this point, we know how many fish were caught, how many fish were counted in total across the escapement towers, and we know what the aggregate age composition is. So then what we did was basically ask, if we pretend that Bristol Bay is just one big stock of fish, can we make a forecast about how many fish are coming back next year? So for instance, in this year, I don't know what year this is 2022, there was about 30% 1-2s which times a big number. It turns out to be a lot of 1.2s came back in 2022, and we can use those to predict 1.3s for 2023. And anyhow, we started doing this, and it turns out that our predictions based on the aggregate data available around the 1st of August makes a pretty good forecast for how many fish are coming back the following year. So we did this for a couple of years before we did one that was sort of official. So if we compare how this method would have done for 2022, had we used the data available the 1st of August, we would have forecast about 70 million fish in 2022. And then our official preseason forecast that was available by the end of November was 72 million, which, you know, from the perspective of the fleet or even the processors and probably the managers, these two numbers are quite comparable. The observation, of course, that came in was over 80 million. But the point is by August 1st, we had a pretty good indication that a huge run was coming for 2022. What's different about the full-blown preseason forecast that's done after the run reconstruction is we have river-specific forecasts that we can't really do with the data in hand, or we haven't tried to do it with the data in hand in August. But you know, by November, our preseason forecast has a lot more detail in it than the aggregate that we can come out with in August. If we look at last year, our preliminary forecast in August was about 49 million fish. You know, several months later, our forecast with all the details was about 50 billion fish. So again, very comparable and not that far off, about 10% off from what actually showed up in last summer of around 55 million fish. And we've assessed this back through time, and we're happy that we had enough confidence to do these preliminary forecasts that we should start putting them out. So in 2023, in August, we put out a forecast that we're calling a preliminary preseason forecast. In August, that number was about 39 million. The full-blown preseason forecast we came out with in November was close to 45. So a little bit of difference there. The difference was that I think it was U.Washington, a lot of jacks showed up late, which bumped up the U.Washington forecast that came out in the official preseason forecast. But the point is we're predicting a sort of a middle of the road return, and we could have done this in August. We don't know what the observation is, as we're hoping it's going to be somewhere in this ballpark. But at this point, moving forward, our plan is to use the data end of July or early August, as soon as Fish and Game does their final releases for the season, and we'll come up with a preliminary forecast that people can use for thinking a year ahead in their own planning. And you know, the intention here is not to replace our official preseason forecast, but just to get people a few months lead on how to plan for the upcoming season. And we can take questions for that at the end of my presentation here. I want to move briefly into the state of the climate and the state of the ocean temperatures. And of course, for those who've been awake at the wheel, the last decade has been really warm in Bristol Bay and throughout the Northeast Pacific. This, we know, is part of the trend that is we're seeing in terrestrial environments, in freshwater environments, and in the ocean. That's a result of climate warming on top of changes in the periodic forcing of climate. And if we look at Bristol Bay between 1960 and around 2000, we see a general pattern of warmer conditions when smolts leave for the ocean typically result in better returns. So if we look at this top panel here, here's a map of Alaska. Here's the Alaska Peninsula coming out. Here's Bristol Bay. And what's being plotted here is for each area of this map, we're plotting whether that time frame was warmer or colder than the average. So in years where we had highest survival rates of Bristol Bay salmon, there's lots of greens and yellows here. which means that they were warmer than average for those good years. And if we go to the bottom panel, these are the 10 worst years for Bristol Bay marine survival. And you can see it's mostly blues and purples, which means on average, when conditions are cold, we typically see weaker returns of Bristol Bay salmon. So over the last few years, of course, we've had lots of warm temperatures, and that seems to translate into these higher survival rates of the smolts when they hit the ocean. So Chris showed the same figure. This is the buildup of Bristol Bay sockeye over the last, what is that now, close to 70 years. And of course, since 2013, or about this last decade, we've been in a different productivity regime where the average is close to 55 or 60 million fish. The 45 or so that we're predicting this year is basically still in line with what appears to be this at least 10-year regime of very high productivity for overall in Bristol Bay. So what are the temperatures that produce this? Here again is that same map, 2014 to 2019, which are, if we think about this as the year where the smolts hit the ocean. Again, here's Alaska, here's the peninsula. And here are these temperature anomalies. Yellows and reds are warmer than average. And basically, we see that the southeast Bering Sea, eastern Bering Sea, and Bristol Bay have been substantially warmer than average, on the order of, almost 2 degrees Celsius, so almost 4.5 degrees Fahrenheit warmer than average for that time frame. And the Gulf of Alaska, where the fish are putting on most of their growth, has also been warmer. So as climate warms, whatever's happening in the ocean, we don't really know what the mechanism is, but it seems to be benefiting Bristol Bay sockeye, particularly those on the west side. In fact, places like the Kuskokwim sockeye have really gone through the roof. Of course, the Nushagak has gone through the roof too in terms of its production. So something's going on in the ocean that's profiting those smolts when they swim out. And it's correlated with these really warm temperatures. So if we look at these year by year, these are the same temperature anomaly maps that fish would have encountered that are returning this year. So let's just look at 2019 as a starting point here. This is that summer where we rewrote the temperature records for Alaska. And again, here's Bristol Bay, and you can see this deep red color. The temperatures were 2.5 to 3 degrees above average for June, July, and August in 2019. And this may be a foreshadowing what we're going to see in the next couple decades or two with further climate warming. The good news is 2019 and that smolt year actually produced a lot of fish that came back in 2021 and 2022. So it looks like there is a lot of capacity in Bristol Bay for ongoing climate change. If you look at 2020, 2021, 2022, the last 2 smolt years that are relevant to returns this year, we're actually more towards normal. So in 2021, smolts that left that year will be returning this year as 3 oceans. And you can see there's some white here in the Gulf of Alaska and some modest yellows. So things were warm, but they weren't as hot as they were in 2019. If we look at 2022, those smolts will be returning as 2 ocean fish this year. And, the forecast is down a little bit, and maybe by coincidence, maybe by some connection to the climate, you can see that Bristol Bay was actually a bit cooler than average in the summer of 2022, which correlates with our slightly down forecast compared to the last 10 years or so. So if we look at the time scale, I think this is interesting to put it in the perspective of how warm the eastern Bering Sea has been in the last 70 years or so. And you can see prior to about 77, the average summer temperatures were around 9 degrees Celsius. Mid-70s, we bumped up a little bit, about 0.5 degree. And then in this since about 2013 and 2014 is where we got these so-called warm blobs, these really exceptional hot water temperatures that hit in 2014, 16, 19. Things have cooled off a little bit in the last 3 years. So they're closer to normal, but they're still substantially warmer than what would be considered the long-term average over the last 70 years. So there's been a bit of a cooling trend towards what might be considered normal, but it's still on the warmer side of the average, which, just to remind you, has correlated with higher than average returns of Bristol Bay sockeye. Gulf of Alaska, which is less relevant to smolt survival, but it is relevant to growth. Bristol Bay sockeye has also been warm the last decade, and there's also been this slight cooling trend in the last 3 years. And this is the Gulf of Alaska in red on top and Bristol Bay on the bottom. The same temperature regimes or temperature time series I just showed you. But the point here is that the Gulf of Alaska is always, 3 to 4 degrees warmer than the Eastern Bering. So during these years where we had really warm temperatures during those warm blob years, there was actually pretty poor recruitment of sockeye from rivers that dumped directly into the Gulf of Alaska. Whereas rivers that dumped into the Eastern Bering and Bristol Bay, this warming seemed to benefit those fish. And there's still a lot of room here for Bristol Bay smolts to deal with ongoing warming if it continues into the future. Talk very briefly about where we are now. This is a loop. I was going to run it, but it doesn't seem to work very well. But this is sea surface temperatures. I'm not sure what date this is, but this is for a range. But what we're looking at here is the North Pacific. Here's Bristol Bay. And again, these are anomalies. These are temperature differences from what would be considered normal for that place and time. And here's the equator right here, which of course is not relevant directly for Alaska salmon, but the temperatures on the equator tell us about the strength of El Nino. And for those of you who are skiers or wannabe skiers, you've known that this last year has been really hot. There isn't a lot of snow around, and that's because we've been in this really strong El Nino phase, showing up as really hot water temperatures right on the equator. What you'll see if in the next slide, which is the observations yesterday, is that that stripe of really warm temperatures on the equator has started to dissipate, and in fact some cool water started to creep up onto the equator, which tells us we're going back into a La Nina phase. And that gives us some indication of what the climate will be like for the next couple of years if this La Nina condition persists. So as you can see right now, Bristol Bay is actually a bit cooler than average. But we expect some carryover from this residual El Nino into temperatures this summer. So this is kind of an ugly figure, but again, here's Alaska. Here are contours of the expected temperature from average. And the expectation for this summer is orange and red, which means we're expecting that sea surface temperatures relevant to Bristol Bay sockeye is going to be substantially warmer than average this coming year, this coming summer. And here you can see this very deep blue stripe right on the equator. This is the signature of La Nina, going back to La Nina conditions. And from a terrestrial standpoint, this is a different climate forecast. This is for North America. Again, reds tell you it's expected to be warmer than average. And Bristol Bay is, the forecasts are supposed to be slightly warmer than average for this coming summer. Not some of the really extreme temperatures we're going to see throughout central Canada and down into Mexico, but still warmer than average is the expectation for this coming summer. So the outlook from a climate standpoint, we've been through some incredibly warm temperatures, and they've been an interesting test, if you want to think of it as that way, of the resilience of Bristol Bay sockeye to climate warming. And as you know, the fish have done really well despite these off the chart water temperatures. Hopefully those relationships will continue into the future. We're expecting this warm spring as the El Nino winds down, but it's expected to end by this spring, and La Nina is going to start setting up for next fall and winter. So skiing next year should be better than this year. So I'm happy to take any questions if there are any.
Thank you. Yeah, Rachel, and go ahead and you should be able to speak now.
Yeah, hi, thanks. Thanks for all the presentations. They're really great. Dan, I was wondering, how does what you're sharing with regard to the higher sockeye productivity and the warming temperatures in recent years, how does that compare with what happened in the late 90s? Like I saw you had 97 on the graph explicitly called out, and it seems like I had thought at the time that was because of a couple degree temperature in the sea. It seems like it's shifted, or do you know what's going on?
Yeah, thanks, Rachel. That's a good question. I mean, 97 was a weird year for lots of reasons that didn't really fit the pattern. Yeah, I don't have a good explanation or answer for you, except that this last decade, we've really had this, this new regime of really warm temperatures that have been persistent for, several years in a row. And that wasn't the case in the 90s. The big shift in the ocean regime occurred in the late 70s. So that's when the PDO shifted to what we call a warm phase. The temperature of the North Pacific warmed up a lot, particularly on the coast. And that's when Bristol Bay sockeye production pretty well doubled after 76, 77. And it bounced around. There were some good years and some bad years until around 2010. And then it seems like we're in yet another step up in terms of the regime, the productivity regime. So yeah, 97 was a mystery for lots of reasons. I don't know. Don't think anyone has a firm handle on why it was weird.
Oh, okay. Yeah, thanks. That's really interesting. I was also curious if you, or I don't know, maybe Chris or Curry have thoughts on this, but are you anticipating growing differences in FRI forecasts and ADF&G forecasts based on these different modeling choices? And if so, do you guys have any thoughts on like management implications around those differences?
Well, I mean, the reality is the data used to inform those forecast models is the same, and the methods are slightly different. Our forecasts tend to be quite correlated with each other. Sometimes they're a bit higher than us, sometimes they're a bit lower than us. So the data are really what's driving the forecast, and because we're using the same data, they're often very similar. I don't think they're different enough to have any implications for management. Curry may have a different answer.
No, I was going to say exactly the same thing. We're all looking at the same data, right? In general, kind of sibling returns in prior years, abundance. Yeah, so we tend to have fairly similar forecasts historically. So I don't know about any specific implications.
And the good thing about Bristol Bay is the data sets we can use to make these forecasts is really rich. A lot of places don't have data sets anywhere near this good. So as a result, the forecasts are driven by the data more so than the method.
Okay, thank you so much.
Thank you. Fritz, go ahead.
Thank you, Francis. Dan, thanks for being here. Here's my question is El Nino versus La Nina. Do the temperatures reflected in either one, are they relative temperatures or are they absolute? I guess my question is, if we're in an El Nino period and it starts to cool, does that make it a La Nina and vice versa? And I'm also curious as how both of those trends relate to the Pacific Decadal Oscillation, and which is a 26-year period. Is that correct, or something like that?
Yeah, thanks, Fritz. Good questions. Well, a couple things. Whether it's an El Nino or a La Nina is really determined by the temperatures on the equator. So the climatologists are looking at the sea surface temperatures on the equator, and if it's warmer than average along the equator, they call it a El Nino. And if it's colder than average on the equator, they call it a La Nina. And those temperatures don't matter to Alaska fish, but what those temperatures on the equator does is they translate it to differences in climate that Alaska feels. And it turns out that for El Nino and La Nina, by the time you get to Alaska, sort of that, we call it a teleconnection, where equatorial temperatures translated to differences in weather farther north or south. By the time you get to Alaska, the El Nino La Nina impact is fairly weak compared to PDO. And Pacific Decadal Oscillation, as you said, has a much longer periodicity. It's more like a full cycle is more on the order of 50 to 70 years. And the big jump up occurred in the mid-70s, and the PDO was in this strong warm phase till about 1999 or so, 2000, and then it's been pretty neutral. Since then, we've discovered yet another cycle, which is the North Pacific Gyre Oscillation, which is related to PDO, has a shorter time scale, and is superimposed on it, and it seems to be correlated with higher, at least sockeye returns and pink production in Alaska. So all these cycles are playing out on top of each other. The weather as we experience it seems to be quite closely tied into El Nino and La Nina. The climate that matters most to the fish, for whatever reason, seems to be much more correlated with the PDO and the NPGO, which, as you say, has these longer phases. You know, this current phase we're in during the last decade is associated with this warm phase of NPGO.
Well, complex to say the least. Thank you, Dan.
Yeah, it's complex. We could BS about this forever, and unfortunately, coming up with very specific predictions from climate to fish production is a tough one to do. What we know is sort of generalities. When the coastal ocean is warmer in Bristol Bay, smolts tend to do better. And one of the questions looking forward is how long will that continue to be a productive place for sockeye with the ongoing climate change that we're seeing? But it looks like we still have, I would say, lots of reason to be optimistic that Bristol Bay smolts will continue to have good conditions for a while to come yet.
Very encouraging for sure. Thank you, Dan.
Okay, our last panelist today is Dr. Ray Hilborn. He is also a professor and principal investigator at the UW Alaska Salmon Program since 1995. He works on salmon management, including escapement goals and run forecasting and comparing environmental footprint of Bristol Bay sockeye to other sources of food.
Great, thanks very much. Can you confirm you can hear me and that you can see my screen?
Confirming all.
Okay, excellent. I'm going to switch gears a bit and talk about our in-season understanding of run strength. So in addition to providing preseason forecast, as most of you probably know, during the fishing season, about every 3 or 4 days, we provide updates which interpret the data as they come in. And I should apologize, I'm relying on Elon Musk and Starlink at the moment, and occasionally the leafing out trees near me block, so I may freeze up for a few seconds. Usually I can figure out that's happening and stop. Okay, so let's go. Come on, why? Okay, there we go. Okay. So this slide shows the information that are available both before the season starts and then as the season develops. So as Daniel showed you with the sort of the annual cycle, we have a preseason forecast that we put out usually in late November, and it forecasts the total return by river. And that's really the only information we have until we get to June. And then starting in June, we start accumulating a whole bunch of different kinds of information. And again, the Bristol Bay is incredibly data rich in comparison to most other salmon runs. So we have daily catch and escapement estimates that I think, I'm sure you all see the dailies as they come out. And some of these are estimates, but they're very reliable. Again, Bristol Bay is blessed with the ability to count fish reliably by counting towers in all the systems except the Nushagak. And that is extremely unusual. There's not very many places that have major salmon runs that really can tell you on a daily basis what their escapement is. Then another piece of information we get in reasonably early June is the catches of sockeye in the South Peninsula fishery. There's some information in those, but really then the next kind of information we get is we start getting information on size and age, both from the Port Molar test fishery and from the catch that's occurring in Bristol Bay. Then we also get genetic information from Port Molar. And what the genetic information does is it tells us which rivers the fish being caught at Port Molar are heading to. The Port Molar index tells us something about run timing, and I'll talk about that. And then the Port Molar index itself, that is, are they catching lots of fish at Port Molar or few fish? And I'm going to talk a little bit about how those things go into the information that we're able to provide as the fishing season goes along. Okay, come on, go down to the next one. There we go. Okay, so this is a graph that we put out that really shows you how the various kinds of information blend as the season begins into what is our in-season estimate. And so on June 10th, test fisheries beginning, there's usually been no significant catch or escapement by that date. So we're relying 100% on the preseason forecast. And then so the Port Molar fishery begins on June 10th. And by the 17th, we really have the first time we start to use the Port Molar information in the forecast. And by that point, we often have some information from the catch and escapement. So the color weighting shows you how we weight the forecast. So 17th of June, it's still almost all based on preseason. It's a little bit based on Port Molar and a little bit based on catch and escapement. But if we then go on to, let's say, June 27th, by that point, the Port Molar information is starting to be distinctly more important, and the catch and escapement data is also more important. And so the in-season forecast is more or less 50% weighted by the preseason estimate, maybe 30% by Port Molar information, and then the catch and escapement to date, maybe 20%. But if you go to 10 days later to June 10th, it's almost all based on catch plus escapement to date. By that point, we've seen much, if not most, of the run. And so as we proceed through the season, our in-season forecast depends differentially on those sources of information. And catch and escapement is the gold standard, because by the time you have most of the catch and escapement, the run is on its way down, and the major source of information before this happens is coming from the Port Molar test fishery. And the information coming from the Port Molar test fishery that we use the most is the timing. We look at when that index starts to drop off. If it drops off early, we're looking at an early run, and the catch and escapement to date is going to overestimate the total run. But if the index is building into July, it usually means a late run, and that means that the cumulative catch and escapement to date is going to underestimate the run. So 15 years ago, we would calculate the prediction based on catch and escapement to date, assuming average run timing. And as the Port Molar index we've started to realize how much information there is in the timing, we're adjusting the catch and escapement to date based on whether Port Molar is indicating it's an early run or a late run. And if you follow our reports every few days, you'll sort of see that in there in early July. We'll say, basically, if Port Moller continues to build, we'll expect we may be at the higher end of the range. If Port Moller has declined, we're going to be at the lower end. And that's, I think, well, that's really important. And the bottom line is that the magnitude of the index has really not proven helpful. When I first got involved in the FRI program in 1995, Don Rogers was a real believer. He was running the program in those days, at that the absolute number of fish caught at Port Moller was telling us a lot about how many fish were coming. And if you were around in 1997, where the run came in well below the forecast, Don was convinced that they'd seen lots of fish at Port Moller. Chris Boatright was out on the test boat at the time, and they caught lots of fish. And Don just couldn't believe that those fish weren't going to show up in the bay. And we stopped running the Port Moller test fishery in the early 2000s, and BBSRI took over, and they've made a lot of changes with a 2-boat system, with trying to avoid net saturation. And it just isn't working in terms of producing an index. The big catches at Port Moller simply don't indicate a big run, the low catches. But the timing information from the Port Moller index has proved very helpful. So the question is, what does the genetics tell us? And so what and they've got this very sophisticated system now where they've got a genetics lab on board one of the 2 boats, and the genetics gives us an idea of what proportion of the run is headed to each river. And also some of this in the pattern. So we look a lot at when Kvichak and Naknek start to build, because particularly when Kvichak starts to build as a percentage of the run, it tells you you're getting later in the run. So that's more information about timing. But we really have 2 estimates of the portion of the fish of the run that's headed to each river. Because remember, the genetics doesn't tell you how many fish are going to Nushagak or how many are going to Kvichak or Egegik. The genetics just tells you what proportion of the run is going to those places. And we have really 2 sources of that proportion. We have the preseason forecast, which Chris showed you, and we have the Port Moller genetics. And this slide compares the absolute error as a percentage of the information available to managers on the 30th of June from the preseason forecast compared to the Port Moller. And the surprising thing is the preseason forecast has proved a little more reliable than the Port Moller. So it's not as if the Port Moller data is giving us better indication about where the run is headed than the preseason. They both give us information about that. They're based on different kinds of things. But on average, the preseason is a little bit better. It depends a lot on the river system. But in general, the preseason forecast provides a little bit of better information than the Port Moller genetics data do about where the run is headed. Let's see. So, but both methods provide useful information. Surprisingly, the preseason forecast has proven a little more reliable for both districts, but they both add information to that critical time towards the end of June. And the bottom line is that we should use both. So that's the end of my presentation, and I'll take any questions.
Thank you. Yeah, go ahead and raise your hand for anyone who has questions on Ray's presentation or any of the others. We reached the end of our presentation, so happy to take questions. Give it just a minute in case anyone's battling technology. All right, well, thank you all so much for these presentations. It's a lot of information and it's really good information, and I was happy to see good turnout here today. I know as a fleet, we're all, want all the information we can have about the upcoming season. So really appreciate you making that time and making yourselves available to the fleet. This was recorded and I will post it up as soon as I can, but by Monday, certainly, if you'd like to listen again or share it with someone who wasn't able to be here.
Sorry
ahead, Carrie.
to interrupt you. There are a couple questions that popped up while you were speaking.
Excellent. Go ahead.
Let's see. Their hand raised. I think Jameson.
Oh yeah, Jameson Ramsey, you should be able to speak now.
Yeah, can you hear me?
Yes.
Okay. Yeah, I had a question earlier on about your ocean harvest when the fry out in the ocean. And I mean, are the fry looking healthy out there? Is there any signs of disease, predator, any other abnormalities that you see in the Bering Sea fry harvest or fish at sea?
Yeah, thanks for the question. Part of the information that's collected from those fish that are caught in the high sea surveys is sort of length and weight and condition and that. And so we looked a bit at whether or not the condition of those fish, whether they're sort of heavy or light for a given length, what you control for their length, was a reasonable predictor of run strength in future years. And it didn't really seem to be. In general, there haven't been large changes in condition out there, at least from what we've seen on those high sea surveys.
Okay, thank you. Thank you very much for the info.
I just had a quick follow-up comment, if I might. Ray did a great job of talking about our kind of in-season forecasting process. And so those in-season forecast reports are available on the FRI website as the season unfolds. And we also have a website that Chris and I update on a daily basis with a few summary figures and that will update day over day that are available to the fleet for folks who happen to have internet access. So I'll put the link in the chat for that where it'll appear.
Yeah, I also forgot to mention that we've got another piece of information that we've just started to use that Daniel and one of his students had been looking at the relationship between the average size of fish as the season develops and the total return. And so it's been noted for a long time, again, going back to the 1970s, Don Rogers used to use that as part of his, that if the fish are small, the run is likely large, and if the fish are big, the run is likely small. And so I don't think that's been officially incorporated in the in-season yet, Curry, but it's it'll certainly happen this year. And
that's another component we added in last year.
Yeah, okay. It's another piece of information that's available to us.
Although one caveat to that, Ray, is if people see lots of small fish in their nets, that doesn't tell them that it's going to be a big run because they need to be aged.
Yeah.
That's why we wait for the data from Stacy Vega's crowd, who comes up with size at age. So just because you're seeing big fish doesn't mean it's going to be a small run. You really need to account for the sizes of, the ages of the fish too.
Yeah. So it's the 3 ocean fish are bigger than average or less than average. And if the 2 ocean fish are bigger than average and less than average. So, I mean, you see a lot of small fish for 2 reasons. One is they are small at age, and also they're 2 ocean fish mostly. So last year we saw lots of fish, but that was largely because they were mostly 3 ocean fish.
Great, thank you. A few more in the chat. I see our pink salmon caught as well. I'm assuming that's in the ocean trawls.
Yeah, they certainly are. So pink salmon, those data have been used extensively for king salmon further north. Increasingly for chum salmon, we have some work doing similar things for chum salmon throughout, trying to come up with reasonable predictions for at least some chum salmon stocks. And pink salmon are caught out there as well.
Okay, great. And the last question I see here is, are the slides going to be posted to print rather than the recording? I haven't asked you guys that yet, but if you are able to send your slides, I can make them available.
No problem.
I see some nods. Sounds like yes. All right. Thanks again. Lilani, do you want to close this out? Nope. All right. Thank you all very, very much. And thanks for everyone who tuned in as well. And we'll talk to you later.
Dang.
Thank you very much.
Thank you.
Bye-bye.
Thank you for hosting.
Bye.